A well-designed stack-up is key because it maintains consistent transmission line impedance. When we arrange the signal layers strategically, we can keep noisy and sensitive signals separated. Using dedicated power and ground planes for high-speed signals always helps to reduce the noise and improve decoupling. The way we organize copper and dielectric layers also play a big role because it supports the heat dissipation from RF components. If we distribute copper evenly, we can prevent issues like board warping and delamination as well. Let's focus on how to select the best laminate for prototypes. And the first thing that is to choose materials. So when you're selecting materials, you need to focus on dielectric constant stability. It's important to check how the decay values behaves over range of frequencies because some laminates vary at higher ranges, maybe in gigahertz. You also need to consider how the dielectric constant changes with temperature and humidity. Ideally, you should choose materials with a tight decay tolerance around say plus or minus 0.05. And for fast signal propagation, use materials with a lower dielectric constant, typically below 4. We have listed some examples here. We have the Rogers RT Duroid 5880, which has a dielectric constant of 2.2. Then we have Rogers 20, which has a and ISO high speed, which has a dielectric constant of 3.